Hi students, now we are going to discuss about this chapter, priorities. This chapter is very important for NEET and JEE. Okay, so first we can discuss about the reflection. First part, reflection. Reflection. Okay, this topic is very familiar to you. Reflection simply the bouncing back of light ray from the smooth surface. Suppose this is a smooth surface, a mirror. Okay, this is a smooth surface. When a light ray strikes on it, this ray of light is called incident ray. Okay, definitely it reflects back to the same medium. Okay, reflect back. This imaginary perpendicular line is called this. Actually, this is an imaginary line that is called normal at the point of incidence. Normal at the point of incidence. Okay. Here you can see two angles. First angle is the angle between incident ray and the normal. Okay. And second angle, that's the angle between normal and the reflected ray. This angle is called angle of incidence and this angle is called the angle of reflection. Okay. According to the law of reflection, these two angles are equal. These two angles are equal. Okay. Angle of incidence that is equal to angle of reflection. That's the first law of reflection. And second law, these three lines, incident ray, normal at the point of incidence, reflected ray, are lying in the same plane. Okay, these are the two laws of reflection. And you can see one more angle. Actually, this dotted line indicating the actual path of the light ray. So, the angle between this actual path of light ray and this reflected ray, this angle is called angle of deviation. We know this entire angle from this point to this point, this entire angle is 180 degree. So this delta is equal to, according to the law of reflection, these two angles are equal. So we can say delta is equal to 180 minus 2r. Okay. Otherwise you can say 180 minus 2r. Both equations are same because this entire angle is 180 degree and this angle means this angle, that means the reflected ray, the angle between the reflected ray and this actual path of this light ray, that represented here by this dotted line. Okay, so this delta is equal to this entire angle minus this angle. This angle is 2i or 2r, both are equal. So we can write delta equal to 180 minus 2. Okay, next one. The image formation in plane mirrors. Image formation in plane mirrors. Okay. So we can discuss about the plane mirror. Suppose this is a plane mirror. This one is a plane mirror. Okay. These are objects in front of this plane mirror. Okay, an object placed in front of the plane. Okay. So you can see the image of this object. That image will form just behind the mirror only, plane mirror. Okay. Actually, that image is a virtual image. Okay, that image is a virtual image. Here you can see the size of the image. The size of the image and object is same only. Okay, size of the image and the object both are same. Okay, and this image is laterally inverted. That means left side become right. Okay, and the distance between object and mirror that represent as u. This distance same as this distance. Okay, this distance represents as v. Okay, so in this case u is equal to v. Okay, the distance between object and mirror is u, that is object distance, and the distance between mirror and this image, that is called v, or image distance. In this case both are same. The magnification of this image is +1. This positive sign indicating that's an erect image, and 1 indicating the size of the image same as the size of the object. Okay, here that is the image is little bit smaller, so okay, now that's okay. Okay, this is the image, this one is the object. Okay, this one is a virtual image. Virtual image means virtual image always formed behind the mirror only, but real image you can focus a real image on a screen. That's a speciality of real image. Okay, you can focus a real image on a screen. Okay, so real image always formed in front of the mirror. Okay, but and one more thing, real image in front of the mirror always inverted. Okay, if it is a real image, you can say that will be an inverted image, but virtual image always erect. Okay, then in the case of magnification, the negative sign indicating the inverted image. Okay, so just note this point, all virtual images are erect. Okay, and all inverted images are real. Okay, our next topic, the number of images formed by the images of two inclined plane mirrors, or the number of images formed by two plane mirrors. Okay, suppose this is our first plane, this is our first plane mirror, and this is our second plane. Theta be the angle between them. Okay, then see, these are objects in front of us. Okay, so you can observe lot of images behind these two plane mirrors. Okay, the number of images by these two plane mirrors that represented by this equation, that is 360 divided by theta minus 1. Okay, don't forget this equation. The number of images formed by the inclination of two plane mirror, that is n is equal to 360 by theta minus 1. For example, if the angle is 90 degree, if theta is 90 degree, just imagine if the angle is 90 degree, that means two plane mirrors just like this. Okay, two plane mirrors like this. Okay, perpendicular. First plane mirror is perpendicular to second one. Okay, the angle between these two is 90 degree. In this case, the number of images n equal to 360 divided by 90 minus 1. That's equal to, okay, 360 by 90 is 4. So 4 minus 1 is 3. Okay. We have two types of spherical mirrors. First one is concave, and the second one is convex. Okay, these are the two types of spherical mirrors. So first we can discuss about the concave mirror. Okay, suppose this is a concave mirror, this one is a concave mirror. We have this midpoint of this concave mirror, that is called a pole of the mirror. Okay, pole of the mirror. And actually every spherical mirror is a part of a big sphere. Okay, just imagine this is that sphere, this one is that sphere. Okay, just imagine the center of that sphere, it's represented by C. That center is called center of curvature of the concave mirror, center of curvature. Then here I am drawing a straight line passing through these two centers. Centers means this center is pole and this center is center of curvature. Okay, this is an imaginary line passing through, that's a straight imaginary line passing through two centers, center of curvature and pole. Okay, this line is called principal axis. Principal axis. Okay, so in this case every images and object distance, everything is related to this principal axis. We can measure the height of the object, height of the image from this principal axis. Okay. Then when a ray of light going parallel to the principal axis, when a ray of light going parallel to the principal axis, okay, this ray of light going parallel to the principal axis. After the reflection, definitely that reflect towards the principal axis. Okay. So these are the incident rays. These are the incident rays going parallel to the principal axis. After the reflection, you can see all the reflected ray will go through a common point in the principal axis. See, all the these are the, see, 1, 2, 3, 4. Okay, 4 incident rays are going parallel to the principal axis. After the reflection, this is the first reflected ray, this one is the second reflected ray, this one is the third reflected ray, this one is the fourth reflected. All these reflected rays will meet at this point. Okay, this point is called principal focus. That's called the principal focus. Okay, then the distance between these two, pole and focus, that is called the focal length, represented by small letter. Focal length. And the distance between C and P, center of curvature and pole, that is called radius of curvature. Okay, radius of that sphere. Actually, that is the radius of that sphere. Okay, so the relation connecting F and R is focal length and radius of curvature is R equal to 2 or F equal to R by 2. This is the relation connecting focal length and the radius of. Next, the image formation and the sign convention in concave wave. Okay, that was very easy and interesting topic. See, image formation and ray diagram you already studied. See, this is a pole. This one is the principal focus. This one is the center of curvature. Okay. Already you studied about the ray diagram for each position of image and object. Okay, so here I am saying each position of image and object briefly. Okay, suppose this first position of the object beyond C. Okay, if you place the object here, that represented by 1. Okay, that's our first object. Here we will get the first image. Okay, if you place the object here, definitely we will get the image here. 2 dots representing the second image. Okay, 2 representing the first object. I'm sorry, second object. Okay, if you place the object here, that's our third object. Here we will get the image. 3 dots representing that. Okay. See, if we place the object here beyond C, we will get a diminished real and inverted image. Its magnification value is less than 1, but the sign of the magnification is negative. In this case, magnification is 1, but that is negative. The size of the object is same as the object. That's the specialty of this position. And this image also real and inverted. Here you can see, if you place the object here, we get inverted and real image. But this image is enlarged image. That's a magnified image. Its magnification is greater than 1. Okay. Then one more thing. If we place the object here at the focus, we get a highly enlarged, highly magnified image at infinity. Then another one, if we place, this is our fourth one, this is our fifth one. Okay, if we place the object between F and P, we will get a erect and virtual image behind the mirror. This image is magnified image. Its magnification value is greater than 1 and positive. Positive indicating that's a erect image. Okay? So listen. Next about the sign conventions. Okay, in a spherical mirror, as per the sign convention, all the measurements should taken from this point forward. Okay? If the direction of measurement is against the direction of incident ray, that is taken as negative, otherwise that is taken as positive. For example, focal length of a concave mirror. Focus is here, so focal length, the direction of focal length measurement is from pole to the focus. Okay? But the direction of incident ray along this direction. So, in this case, the measurement of focal length is against the direction of incident ray. Okay? So, that focal length is taken as negative. So, similarly, the object distance, image distance and focal length of concave mirror is negative. But if we place the objects between focus and pole, we will get the image here. At that time only, the image distance become positive. Okay? So, this is a sign convention. And one more rule is there. The measurement above this one, above this principal axis is taken as positive, and below this, for example, the height of the object, that is taken as positive. Below this principal axis, that is taken as negative. These are the sign conventions. In a spherical mirror, the relation connecting focal length, object distance and image distance, that is represented by this equation, that is 1 by u plus 1 by v, and the ratio of image distance to the object distance, that is the magnification, that is represented by this equation, minus v by u, or magnification also equal to height of the image divided by height of the object, and magnification m equal to this relation connecting focal length, object distance and the magnification, that is f divided by f minus. Okay? So these are the relations. Our first question is, to get 5 images of a single object, one should have 2 plane mirrors at an angle of 30 degree, 60 degree, 90 degree and 180 degree. Okay? That's the first question. Okay? You can check that in your material. That's our first question. Okay? So here, that question is very simple. We have this equation, n equal to 360 divided by theta minus 1. Okay? To get the 5 images. So instead of this n, we can substitute 5. 5 equal to 360 by theta minus 1. This 1 will come here. So 6 equal to 360 by theta. Okay. Then theta equal to 360 by 6. So answer is 60 degree. Very easy. Okay. So answer is 60 degree. Now we can discuss the second question. Okay. This is the second question. A man runs towards a mirror at a speed of 15 meters per second. The speed of the image relative to the man is. 4 options you have. 15 meters per second, 30 meters per second, 35 meters per second and 20 meters per second. Okay, these are the options. This is also a very simple question. This question related to the relative velocity. See, suppose this is that mirror. Okay, suppose this is that mirror. This is that mirror. A man runs towards the mirror. A man runs towards the mirror with the speed of 15 meters per second. 15 meters per second. Okay? Definitely the image, this is the image. Image also will move towards the mirror with the same speed, 50 meters per second. So, the speed of image that is along x-axis. So that is taken as positive 15 meter per second. The speed of the man, that is along the negative x-axis, that's against the direction of the image. So that is negative 15 meter per second. Negative 15 meter per second. Our question is the speed of the image with respect to the man. Okay, relative to the man. So the speed of image with respect to man, VIN, that is equal to VI minus VN. That's the equation. Okay, this equation, this is the equation of what? Relative velocity. Okay, this is the equation of relative velocity. So we can substitute here. VI, that is plus 15 meter per second, minus 15 meter per second. So this minus and minus become plus. So we will get 30 meter per second. So 30 meter per second is the answer. 30 meter per second. Okay, our third question is, a virtual image of 3 times the size of the object is obtained with a concave mirror of radius of curvature 36 centimeter. The distance of the object from the mirror is, 4 options you have, 5 centimeter, 12 centimeter, 10 centimeter and 20 centimeter. Okay, here radius of curvature is given, so you have to take the half of that. Okay, that's the focal length. Okay, here the magnification is given. Okay, in this question the magnification is given. Okay, magnification is 3. Magnification is 3. That is given. So focal length, that's a half of the radius of curvature. So here that is 36 divided by 2, that is 18 centimeter. Okay, 18 centimeter. So the relation connecting focal length, magnification and object distance, that M is equal to F divided by F minus 4. Okay, so easily you can substitute. That's equal to, instead of magnification, that is 3, focal length is given, that is 18 divided by 18 minus U. Okay, so easily we will get the answer. See, this 18 minus U is equal to 18 divided by 3. 18 divided by 3. So 18 minus U is equal to 6. Or U itself equal to this minus 18 plus 6 will come. So we will get minus 12 centimeter. This negative value indicating the object is placed in front of the mirror. Okay, in front of the mirror. So 12 is the answer. Okay, our fourth question is, an object is placed at 20 centimeter from a convex mirror of focal length 10 centimeter. The image formed by the mirror is, okay, 4 options you have, real and at 15 centimeter from the mirror, virtual and 20 centimeter from the mirror, virtual and 20 by 3 centimeter from the mirror, real and 20 by 3 centimeter from the mirror. Okay, these are the options. Okay, we can do this. Okay, in this case, the object distance U equal to minus 20 centimeter and focal length is plus 10 centimeter. The focal length of a convex lens is, the focal length of a convex mirror is positive because the image is formed behind the mirror. Okay, behind the mirror. So as per the sign convention, that is positive. But object distance always negative in the case of all type of mirrors and lenses. Okay. So 1 by F equal to, we have this equation 1 by F equal to 1 by U plus 1 by V. By substituting, easily we will get the image distance. Okay. That's equal to 1 by f equal to what? F is given. That's equal to 1 by 10 is equal to 1 by u. U is given minus 20 plus 1 by b. Okay, so 1 by 10 equal to then 1 by b equal to 1 by 10 plus 1 by 20. So by the cross multiplication, 10 plus 20, that is 30. So 1 by b equal to 30 divided by 200. That means 1 by b equal to 3 divided by 20, or b itself equal to 20 divided by, okay, 20 divided by 3. Okay, so image is formed. Actually, the sign of this value is positive. So image is formed behind the mirror. Behind the mirror. So our answer is behind the mirror. Virtual image, the virtual image only formed behind the mirror. So this value indicating minus 20 divided by 3, positive 20 divided by 3 indicating that's a virtual image, because image is formed behind the mirror. Okay, so answer is virtual and at 20 divided by 3 centimeter from the mirror. C is the answer.